All right, today we are going to be doing lesson 6.2. Our objective today is to solve systems of linear equation by substitution. Yesterday, or the other video, you solved systems of linear equations by graphing. So you graph each line and decided where those points intersect, and that was your solution. There are two other methods to solve systems of linear equations, and one of them is called the substitution method. So that is the one that we are going to be talking about today. So as usual, I give you two equations. Equation 1, equation 2. That's a system. Step 1 is to solve one of the equations for either variable. So you pick one, which equation is easier to work with, and two, which variable can you solve for. So for example, if I was looking at equation 1, it would be very easy to solve for y. All you have to do is subtract 2x. Or in order to solve for x for equation 2, all you have to do is subtract 2y. I'm going to do equation 1. So step 1, solve one of the equations for the variable. I'm going to solve equation 1 for y. So that's 2x plus y equals 1. In order to solve this, I subtract 2x, and I get y equals negative 2x plus 1. That is step number 1. Once I complete step number 1, the next step is to substitute. What they mean by substitute is I need to take what I got for y, which is negative 2x plus 1, and sub it in for y in the other equation. So, my other equation is x plus 2y equals 5. So I need to take what I got for y from the first equation and sub it in here. So I'm going to end up with x plus 2 parenthesis, because 2 needs to multiply to everything that y equals 5. Now, we have enough information to find out what x is. We can solve this equation just like we do any multi-step equation. First, we would need to distribute, and we get x plus negative 4x plus 2 equals 5. From here, we combine our like terms, and we get negative 3x plus 2 equals 5. Then we need to get all the numbers to one side, variables to the other side. So we subtract 2, and we get negative 3x equals 3. Last, divide by negative 3, divide by negative 3, x equals negative 1. So now we have the first half of our system, of our solution to the system of linear equations. But remember, when you have a system of linear equations and you're trying to find the solution, you need an x and a y. You need a pair that works for both equations. So we are not quite done yet. We are going to have to do some more substitution. So we found out what x equals, but we don't know what y equals. But if we take x and plug it into either equation 1 or equation 2, we can find out what y is. I'm going to plug it into equation 1. 2x plus y equals 1. So negative 1 goes in for x. And I solve from there. And I get 2 times negative 1, which is negative 2, plus y equals 1. Then I add 2, and I get y equals 3. When you write your final answer, you are going to go ahead and write it as an ordered pair, where x is negative 1 and y is 3. It is very important that you understand what this means. This point means that it will satisfy both equation 1 and equation 2. The next thing that you would have to do would be to check to make sure that you got the right point. In order to check to make sure you got the right point, you take that point and you plug it into each equation to make sure it works for both of them. I'm going to simply just plug it in and let you do the rest. So we take x goes in for -1 plus 3 equals 1. You should end up with 1 equals 1, in which case you were correct. Over here, you take the same thing. You plug in -1 plus 2 times 3 equals 5, in which case you should end up with 5 equals 5, which is correct. So my solution will work. Please go ahead and go through and simplify this on your own. You may go ahead and flip your page now. We're going to go through one more example using substitution. So in this case, again, step 1 is to solve for a variable in either equation. Always pick the easiest equation and the easiest variable to solve for. This first one looks like I'm going to end up with some fractions if I solve for x or for y. That is not something that I want to deal with. So I'm going to solve equation 2 for x. Looks very easy to solve. It takes one step to solve it. So x minus 4y equals 9. Add 4y to both sides. And I get x equals 4y plus 9. Step 2. Sub x into equation 1, or into that other equation that you did not solve for initially. So I take that x and I take equation 1, which is 2x plus 5y equals 5, and I plug in what I got, which is 4y plus 9. So 2 times 4y plus 9 plus 5y equals 5. From here, we distribute. We solve for our variable y. We have 8y plus 5y, which we can combine to get like terms. And we get 13y plus 18 equals 5. From here, you should know how to solve this. You subtract 18, and you get 13y equals -13. Solve for y. Y equals -1. So, from here, now that you have that y equals -1, you take that y equals -1 and you plug it back into either equation, equation 1 or equation 2. I'm going to go with equation 2 because I want to solve now for my x, and that looks like it's going to be pretty easy to solve for. So I have x minus 4y equals 9. I take that -1 and I get x minus 4 times -1 equals 9. And I get x plus 5 equals 9. And then from here, we subtract 5, and we get x equals 4. Again, when I write my final answer, it needs to be written as a coordinate or as a pair. So my x was 4, and my y is -1. We know that this point will satisfy both equation 1 and equation 2. To finish off this problem, we would go ahead and check to make sure the point works for both equations.